Hi, this is Mrs. Rodriguez with another lesson video. Today we're looking at how to apply equations to proportional relationships. So in our previous video, we looked at how to create a proportional equation. And today we're going to take those equations that we create and apply them to answering questions. So let's go ahead and review a couple of things. First off, don't forget your equations are written as y equals kx. And that k is your unit rate. Okay. Then what you're going to do is you're going to find the unit rate and you're going to plug in that number value into y equals kx. So it should end up being, for all your equations, y equals some number times x. Now remember, y and x are more than one number. They represent more than one number. So we have to keep them y and x. We have to keep them as variables because they do represent more than one number. They change. However, our unit rate is a constant. It stays the same number and it works for all the x's and y's if it's proportional. So that's why we can plug in a number for k, but we need to leave y and x alone. Also, don't forget you find the unit rate by dividing y by x. Okay, and once again, x and y are going to be left alone. So how do we apply the equations? Well, first, we need to calculate our unit rate. We need to write our equation. And then once we have the equation, we'll be given x's or y's in the problem. And then all we have to do is plug in the value for the x or the y, whatever we're given, and it will give us the answer we're looking for. So let's take a look at a couple of examples. First example, Jackson's birdhouses. Jackson and his grandfather constructed a model for a birdhouse. Many of their neighbors offered to buy the birdhouses. Jackson decided that building birdhouses could help him earn money for his summer camp, but he is not sure how long it will take him to finish all of the requests for the birdhouses. If Jackson can build 7 birdhouses in 5 hours, write an equation that will allow Jackson to calculate the time it will take him to build any given number of birdhouses, assuming he works at a constant rate. Okay, so constant rate right there. That's another way of saying unit rate. Okay, remember, the unit rate is a rate and it's constant, meaning the number never changes. It stays the same. Okay, the proportion goes up by the same amount each and every time. All right, so we're also given 7 birdhouses in 5 hours. Those are going to be our x and y and what we're going to use to calculate the unit rate. Now, you'll notice the first question is write an equation. So here we go. We need to remember that the unit rate k equals y divided by x. Then we also need to remember that our equation needs to look like y equals that number, our unit rate, times x. So let's get started with finding the unit rate. We have 7 birdhouses in 5 hours. We want to know how many he can build in 1 hour. So k is going to equal 7 divided by 5. And if you do 7 divided by 5, you get 1.4. So in 1 hour, he can build 1.4 birdhouses. Okay? So if we want to know and then we have to write our equation. I almost forgot. So y is going to equal 1.4x. So how many birdhouses can Jackson build in 40 hours? Okay, well, here's the deal. All we have to do is plug in 40 for x, and that will tell us how many birdhouses he can build. So y is going to equal 1.4 times 40. And we get 56. So that means in 40 hours, Jackson can build 56 birdhouses. And that's why equations are so handy, because once you have your equation, all you have to do is plug in whatever information they give you, and you have an easy way of calculating the answer. Okay, so 40 hours, 56 birdhouses. So how long will it take Jackson to build 35 birdhouses? Okay, so once again, we're given a piece of information. Instead of the X being given, now we're being given the number of birdhouses. So 35 birdhouses at 1.4 birdhouses for a certain amount of hours, right? Because remember, X is hours, Y is birdhouses. So we have 35 equals 1.4x. So this means that 1.4 times some mystery number equals 35. So if I want to know what 1.4 multiplied by, then I can do the opposite. Instead of multiplying, I could divide 35 by 1.4, and that will give me what 1.4 multiplied with. So 35 divided by 1.4 will equal x, which equals 25. So it takes 25 hours to build 35 houses. Okay, 25 hours to build 35 houses. Let's take a look at another example. Here we have Al's produce stand. Now, Al's produce stand sells 6 ears of corn for $1.50. Okay, write an equation for the produce stand and use that equation to help you complete the table below. So, first question's asking, what is the unit rate? Okay, well, we know that the unit rate equals K, and K, the unit rate, is Y divided by X. Well, I can look at this table and remember, X comes before Y in the alphabet. W, X, Y, and Z. And that's a good way of remembering that X is always your first set of data. So ears are going to be X and cost is going to be Y. So if I want to find the unit rate for Al's produce stand, then all I have to do is plug in the pair given. Now remember, in tables, there might be missing information, but they're going to give you at least one pair of X and Y's. So here we have 6 and $1.50. So let's go ahead. Our Y is $1.50. 6 is X. So now I'm going to go ahead and divide $1.50 by 6. And that gives us 0.25, 25 cents. So each ear of corn is equal to 25 cents. Okay, so it's 25 cents per ear of corn. What is the equation that would represent this relationship between ears of corn and cost? Okay, so now we need a equation. So remember, our equations for proportional relationships are y equals k times x. So in this case, it's going to be y equals 0.25 times x. Okay, because it's 25 cents for every ear of corn. So that's going to be our equation. Now we can use this equation to figure out the missing pieces of our table. So here we go. I'm going to write the equation at the very top. Y equals 0.25x. Okay, so in our first piece of information, we're given 14 for x. Okay, well, y equals x times 0.25 or x times 25 cents. So I'm going to go ahead and I'm going to do that. 14 times 0.25. And we get 3.5. So it's going to be $3.50. Okay, for 21 ears of corn, we're now on this one. Same thing. They gave us the x, so I'm going to plug this 21 in for x and see what my answer is, and that's going to give me my y. So 21 times 0.25 equals 5.25. So 21 ears of corn equals $5.25. But wait, now it's going backwards. Instead of giving us x, now they're giving us y at $50. Okay, well, we know that, we know that the x is times 0.25 to get y, right? We multiplied by 0.25 each time to the x to get y. So if we want to go backwards and we have y and we want to know what x is, then we divide. All we have to do is do the opposite. We're going to divide by 0.25, and that will give us what x is. So 50 divided by 0.25 equals 200. So how many ears of corn can you get for $50? 200 ears of corn. And that's what makes equations so great, because once you have your equation, if you're given the number of ears of corn or the number of miles driven or the number of gallons given, you plug that in for your x and it will tell you the cost or how many hours or whatever your y is in that situation. So having an equation makes it very easy. You get your unit rate. Once you have that, you can create your equation and then plug any numbers for x and y to solve your problem. Okay, so on that note, if you have any questions or need additional assistance, feel free to make an appointment with me for office hours. I hope you have a great day. Bye.